January the 16th, 2017. You're looking at the Enlil Solar Wind Predictor Map. Now, guys, look across the top of this chart. You can see that Earth is represented by the yellow dot, Mars the red, Mercury the gold dot, Venus in green. The rest are satellites. Now, stereo A in the red square is the one that we use quite often, and notice it's the opposite side of the sun, but it's in the same orbit as Earth, 1 AU from the sun. Notice as it comes around to the yellow dot there. Now, what's happened on January the 12th, a coronal mass ejection was ejected from the sun, and if you were on the yellow dot looking at the sun, it would be coming off the left side. Now, what we've been dealing with here, and this is the second one, and now we have two sunspots that have popped up that are tracing this, is Comet Honda coming in. The one concern that I've talked about from the beginning was as it gets closer to Earth, we've seen comets before cause very huge coronal mass ejections and X-flares. Now, we've got two sunspots that are both alpha as far as magnetic potential now. And when they start varying or getting larger, we'll have to watch that. But they're appearing, we'll take a look at that. Now, guys, the model doesn't really show the size of this coronal mass ejection. Let's take a look at the LASCO C3 and C2 cameras aboard that satellite. These are giving us Earth-facing images. That's the sun represented in the white dot. So, again, just like on the CME model, you'll see the coronal mass ejection leave from the left side. This camera, also LASCO, this is C2. Check it out. Very powerful. Much more powerful than that model indicates. And if you take a look at this on the SDO and compare it to an Earth scale, which we're going to do, you can see how large it is. But again, this has been my concern the entire time. As the comet gets closer to our planet, and the closest approach is February the 11th, but it starts lining up around January the 28th, we need to pay closer and closer attention. Check out the amount of energy in the beginning of the blast. And this is starting a couple sunspots that are coming around. But this was the first trigger, and then this explosion. Just behind it, if you don't stop it, guys, it's hard to see. But in this image, which I overlay to be the same as the scale on the sun in the image behind it, it shows the scale of the Earth to the sun, not in distance. The Earth is 1 AU or 99 million miles away, but in size. Think about that and the size of that blast. Now, some have described this in the last few years as a kill shot. And this is, again, reaction between a negative and positive in this electrical discharge. As you see that second explosion that was not picked up on the Enlil Solar Wind Tracker. We are also watching this coronal hole. Every 9 days, we're getting this pattern set up in this rotation. Now, the sun rotates from one spot. Say you just marked a spot in about 27 days. Also, coming around, same area as Comet Honda, we're starting to see activity. And this is where the explosions were coming from. That, again, these are the 16th images. The explosions came out on the 12th, so it's advanced. Now, we're getting this from space weather. NOAA forecasters say there's 70% chance of polar geomagnetic storms on January the 18th, and that's the impact of the solar wind stream coming from that coronal hole. Now we're in the low 300s as far as kilometers per second. Very high density, but low 300s. We've seen that jump to 700 and 800 kilometers per second, well over 1.5 million miles an hour. And that impacts our planet. It feeds into this volcanic heating of the inner core of the Earth and the increase in earthquakes. But this co-rotating interaction region is going to strike tomorrow. And that's when in front of the solar wind, this co-rotating interaction, or CIR, is expected to reach Earth during the late hours of January the 17th. These are transition zones between slow and fast-moving solar wind. Now, we look at it this afternoon. The speed is 306.7 kilometers per second, but the density is very high, guys. 16.3 protons per centimeter cubed. Now, think about that. A lot of times we'll see that during these high wind speeds, very low, 3 or 4. But the density at the top is already above the scale that's allowed. If you look at it, it goes to 10, and they're showing 18. Solar wind speed in the middle, indicated in red, they call it radial wind speed. Now, in this model, the Earth is at the bottom in blue. Comet Honda is in red. Venus is in gray. Mercury is also in the other shade of gray, and then Mars is on the outside. Guys, what we're dealing with here is, again, this electric universe, no matter what anyone tells you, as these comets pass through space, and this one has about a 5.25 orbit out just past Jupiter and back, it's like building up friction, to put it very simply. And when it comes back toward our sun, that energy is released just like static electricity. If you're walking on carpet and you touch something metallic and you get that shock and that spark, the same thing happens here, but on a hyper mega scale. Remember how, as we watched ISON come in, we saw X flares and coronal mass ejections aimed directly at the comet, stripping it apart, almost as if protecting the inner solar system from even a more devastating reaction. But here's the live information now. Magnitude 7.0. The apparent magnitude will decrease somewhat as it's coming directly in line between us and the sun, because it's going to be harder to see. But it's moving at 30 kilometers per second, and it is 57 million kilometers from our planet at this time. You can break that time scale down. The perihelion, which was the closest approach to the sun, was back December 31st, New Year's Eve. Now it's starting to become more and more apparent. Now we're looking at stereo A images, and these are behind the sun. So the Earth is about 99 million miles away from the sun, so you're looking at probably close to 200 million miles away, but you're seeing Comet Honda, the smaller object move, and that's our planet to the left, the object indicated there. And again, this will pass directly over us February the 11th. The angle from stereo A looks like that will occur faster, but that's just the angle of the camera. Now, it's a little harder to see, but you can see the brightness that's coming up close to our planet. Again, these are stereo A images on the backside of the sun. Now, one thing about stereo A, remember, it is in the same orbit as Earth. It was meant to do that. Check that out, magnitude 7 now. I think that will decrease as far as brightness. The number may go up as it gets close to the sun as far as apparent magnitude. We'll just have to see. But you can see it getting clear and clear on these images. One thing I want to say about this, they're saying it's a relatively small comet. But when you're seeing it that size close to our planet from 200 million miles away from stereo A, it's not that small. But guys, we're watching this. It's a heads up. We're going to pay close attention to it. Again, let's watch for continued coronal mass ejections coming from the sun. We're about to have increased solar wind speed and pressure, and that's going to build into the heat core of our planet. We're going to start seeing these deeper quakes again. Remember the one that was over 600 kilometers in depth just a few days ago? Same things are going to happen, because that energy is being fed into the core of our Earth, and it is heating the core. Not the surface, but the core. But it does have a reaction with our atmosphere. And in the south, we're seeing record warm days now. That's from these increased solar wind speeds from the coronal holes. If we go into a further solar minimum, then these warm days are going to change throughout the rest of this winter. We're watching that too, guys. It's a heads up. Be safe.